Hey everybody, so this is going to be a quick tutorial on how to use G-Power to be able to calculate a required sample size for a given effect size, and also to be able to calculate the actual power achieved in an experiment after you've finished that experiment. So the first thing we need to do is download G-Power. So if I go into Chrome and search for G-Power, I get a couple of different hits. The top hit is actually from UCLA. The one I want is from the University of Dusseldorf that gives me G-Power here. This is where the program's been developed. If I click on that, it takes me to the website for the program, and I can scroll down until I see download. Now, there's a download available for Windows and for Mac. Now, I've downloaded it and I've installed it. Just download the program for your particular platform and install it. And once you do, go back to your desktop. Then what you need to do is launch the program. I'm simply going to do that by using the Windows menu, and I'm going to search for it, G-Power, and click on that to open it. Once the program is open, we can see there's a couple of different things we need to specify. First of all is the type of power analysis. So we can think about a priori means in advance. This is computing a required sample size given alpha, power, and effect size. You could also do things like post-hoc, compute an achieved power. Let's stick with a priori for now. You also want to select the test family that you need. So let's start off with a simple t-test. And then the statistical test you need to specify. In this case, we could use a correlation point by serial model. There's bivariate regression, or what we can do is look at, for example, in this case, a t-test for difference between two independent means. So we could do that for two groups. Then what we do is we need to input our parameters. So what we see is it needs the number of tails that we want. Typically, we'll be selecting 2. The effect size. And here is what we need to estimate the effect size. And it might be based on another experiment. So we might look into another experiment in another paper that did a similar type of manipulation and find out what their effect size was. What was their difference in between means and as a proportion of the standard deviation. And then we could estimate that. If we see that there was a difference in means of 5 and they had a standard deviation of 5, we would have an effect size of 1. We're going to select our alpha error probability. That's always typically going to be 0.05. If we want to be more stringent, our alpha being set at 0.01, we can change it here, but let's leave it at 0.05. And finally, we're going to select our power, and that's 1 minus beta. And Cohen suggested a beta of 0.2 is about as high as you'd want to go, and this really depends on your experimental question and what you are willing to accept in terms of a type 2 error. So if you're willing to accept a 20% chance of a type 2 error, you could set your power to 0.8. If you're willing to only accept type 2 error of 0.05, you would set your power to 0.95. Don't worry about allocation ratio, unless you've got significantly different sizes of groups. Now, what we're going to do is we're going to, in this case, select 0.8 as our power, and I'm going to click on this button to help me determine my effect size. So for example, if I've got a mean difference of 5, as I explained, I could select mean of group 1 with maybe 10 and mean of group 2 was 5, with standard deviation of group 1 being 5 and standard deviation of group 2 being 5, calculates my effect size will be 1 in this case. Now I can calculate and transfer that to the main window, and this is all going to depend on the parameters that you have. I can close that, and then when I click on calculate, what it does is it gives me a critical t-value and degrees of freedom required for the two sample sizes. So sample size 1 would be 17, and the sample size of group 2 would need to be 17 to be able to calculate an effect size, or to see an effect size of 1 with a power of 0.8. So what we can do is see what happens if our effect size goes down from 1 to 0.5. I calculate that again, and it shows that now I need a much larger sample size in order to be able to see that difference with these levels of effect size, power, and alpha. If I increase my power requirement to 0.95, we're going to see that our sample size requirement goes up again. Now it goes up to 105. So that's how we see that our effect size, our alpha, and our beta are all interrelated. So we can do this in terms of t-tests. If we want to do it for an f-test, we might do that in the case of ANOVAs or MANOVAs or linear multiple regressions as well. So in the case of an ANOVA, for example, we might want to calculate our required sample size for a repeated measures with a within and between interaction. And all that means is that you've got more than one group, so 2 or more groups, and they each do the same test more than one time. So for example, I could have group A and group B, and they both do a pre-test and post-test of some kind of intervention. So in this case, what I'm going to do is determine my effect size. So again, I'm going to click on this button, and we can either do that by looking at the variances that might be in the papers that we're looking at, or we can do directly from a partial eta squared that are typically reported in papers as well. So if a partial eta squared of, say, 0.4 gives me an effect size of 0.81. If I calculate and transfer to the main window, close. Then we just go through the steps again. Error probability 0.5, let's give a power of 0.8, and I know that my number of groups, in this case that my example would have been 2, and each did a pre-post-test intervention. I'm going to leave my correlation among repeated measures here as estimate of 0.5 because we don't know at this point. Now all we have to do is click on calculate. And what we see is for this effect size and a repeated measures, I only need a total sample size of 6. And this will give me a large power. So what we see is this effect size is actually quite large in this type of samples. If I see a partial eta squared of 0.4, we see that's quite high, especially if I'm willing to accept a power of 0.8. If I need a higher level of power, 0.95, I calculate that, we see that my total sample size goes up. Again, because it's a repeated measures, it doesn't go up as much. I only need a total sample size of 8 in this case. We can also do the same thing for linear regression. It just uses the same test here. If I go to linear multiple regression, R squared increase. Again, we can determine our effect size direct from partial R squared. And we can get that from our paper as well. Calculate that and put that effect size into the main window. And we select our error probabilities and our number of tested predictors and our total number of predictors. If I calculate that, it will give me a total sample size required for that test as well. So finally, the last thing I'm going to do is I'm going to see what happens if we do a post-hoc test. So this is computing the achieved power given alpha, a sample size, and a known effect size now. So now if I know what my effect size was, if I've calculated that from my paper now, so for example, if I did an f-test in the same example where I've got an ANOVA of within and between interaction, and I know that my partial eta squared now was not 0.4, but it was 0.236, 0.235. Calculate and transfer to the main window. And then I know that my sample size was actually 12, 2 groups, 2 measurements, and now I can calculate. And what we see is it gives me our critical F and my power. My power was actually 0.93, which means my probability of a type 2 error was only about 7% in this example. Because power is 1 minus beta, which is actually your probability of a type 2 error. So, hopefully that gets you started with using G-Power. Go into the program, try it out, play around with it. It's really quite easy to use, and you can use it with all kinds of different tests.